centimeters square. So now we go to the next part, which is to find the ratio of areas using intermediaries. Now, intermediaries are just like a middleman. So you couldn't go directly, you go through someone or something else. And sometimes in the questions, you don't get enough information to find the ratio of the areas of the triangles that you want directly. So use an intermediary or a middleman. So for example, in this diagram over here, the question may ask you to find the ratio of the area of ACD, right? Sorry, ACF, okay, to FED. So these two triangles, okay? But there is no direct relationship between these two triangles. But they both have a relationship with CFD because using the formula half base height, because they have the same perpendicular height, and these two, they have the same perpendicular height. Right? So what you want to find is actually here, which is area of ACF over area of FED. Now we can first find the area of ACF over the area of CFD, like that. And using CFD as an intermediary, we can also find the area of CFD over FED. And when you put these two fractions together, you actually cancel both of them out, and therefore what's left is what you want to find, because CFD cancels itself out. You may also get a situation like this, where you're supposed to find the relationship between AFB and BED. They have no direct relationship with each other, but they both have a relationship with CBD. So AFB and CBD have a relationship through similarity, and BED and CBD have a relationship through formula. Now, if you want to find the relationship between the blue and the green, this is the ratio that you want to find, or the fraction. So we can find this to this, and then using CBD as an intermediary, we can find CBD over BED, and then we put them together and we cancel each other out. That what's left will give you this. Okay, again, triangle CBD cancels itself out. All right, so over the next few examples, I'm going to show you how we play with this idea in questions. Now let's take a look at this question. In the diagram below, QCB, which is this one, okay, and RABP, which is this one, are straight lines, and QR is parallel to CA. So A asks you to show that QRB and CAB are similar. So QRB is the big one and CAB is the small one. That's easy. We've done this so many times already. So first we say that this is a common angle. So angle CBA equals to angle QBR. Common. And this is the first A. And because they are parallel lines, the blue ones are equal. Angle BCA equals to angle BQR. And this is corresponding angles because CA is parallel to QR. That is your second A. Therefore, triangle QRB and triangle CAB are similar. So you have just answered A. Now look at B1. Given that QR equals to 10, okay, that's already written down. RB is 12, also written down. PB is 4, yep. CA 5. Calculate the length of RA. So RA here, right? So you got the big one, and you have the corresponding set here. So you can find the small one here over the big one. This equals to the small one over the big one. Once you get this, you can find the difference between 12 and this, you get this. All right? So let's give it a shot. So we can say that AB over RB, which is the small over the big, is the same as CA over QR. So we don't know what AB is, but we know RB is 12. CA is 5, QR is 10. So AB will be 5 over 10 times 12, which will give you 6. So this is 6. Therefore, RA will be 12 minus 6. That will also be 6 cm. Okay, so that's the answer for B part 1. Next, they ask you to find the area of triangle CAB, which is this one over here, over, or the ratio of the triangle CAB to the ratio of triangle QRB. QRB is the big one. So we can use similarity to solve this. Okay, so just area of triangle CBA over area of triangle QRB is equals to the length of the short one, which is CA, over the length of the big one, which is QR squared. We know this is 5 over 10 square. That gives you 1/4. So area of triangle CBA to the area of triangle QRB is 1:4. Okay, so let's do part 3 or part A. Oh, this is part 2. Haha, sorry, confused myself a bit. B part 3, area of PQB. PQB would be, oops, sorry, this part here. Okay, over CBA. CBA will be back to the green part here. Okay, so they have no direct relationship with one another, but CBA has a relationship with QRB, and PBQ also have a relationship with QRB. So we use QRB as an intermediary. So let's look at what we want to do. Okay, so this is back to the green. Okay, we're going to say here that area of triangle PQB over area of triangle. Okay, let me just put this in green so that you can see it clearly. Area of triangle CBA. Right? This will be the same as area of triangle PQB over the intermediary, which is area of triangle QRB times the area of triangle QRB, the intermediary, now this time on top, over the area of triangle CBA. Okay, so the first set here, keep doing that. PQB over QRB. So PQB over QRB, the relationship is one of formula. So you can write here half base height over half base height, and immediately you can cancel the half and the height. And then if you look at the second one, QRB over CBA is actually this fraction here, but inverted. So I'm going to put here 4 over 1. Now, if we go back to the left side, okay, the base of PQB will be 4. And the base of QRB will be 12. And this is 4 over 1. So you cancel this, combine them together, 4 over 3. And there you have it. Area of triangle PQB to the area of triangle CBA would be 4:3. You get it? So use the intermediary here, which is QRB, to find two different fractions, and then you combine the fractions together to get this. Okay, go and try some more later on. Okay, let's try one more question. In the diagram, PBR, and PAQ are straight lines. QR is 7.5, AB 5, AC is 3, and QR and AB are parallel. Find the length of RC. Okay, so you find RC, right? You must first prove that these two are similar. And you have one scale factor here already. So you can take the corresponding one here. Okay, so to prove they are similar, first we say that these two angles are the same. So angle RCQ equals to angle BCA. This is vertically opposite angles. So that's A. And because they are parallel, then these two are the same, alternate angles. So angle CRQ equals to angle CAB, alternate angles, because BA is parallel to RQ. That's A. Therefore, triangle RCQ and triangle BCA are similar. So once they are proved that they're similar, we can use the scale factor to find RC. So RC over the corresponding CA will be the same as RQ over the corresponding AB. So substitute the values that you have. CA is 3, RQ is 7.5, and BA is 5. So cross multiply 7.5 over 5 times 3. That will give you 4.5 cm. So that's the answer for A. Now B, if the area of triangle CBA is 25 centimeters square, find the area of triangle CQR. So this is also using similarity, but for areas. So this one over here and CQR here. So let's put it together. Area of triangle CBA, sorry, you want to find CQR, so you actually should put the unknown on top. Area of triangle CQR over the area of triangle CBA is the same as the scale factor. So the length of the big, which is RQ, over the length of the small, BA, squared. So area of triangle CQR is what we want to find. CBA, the area of CBA is given to you as 25. This would be 7.5 over 5 squared. So area of triangle CQR will be 7.5 over 5 squared cross multiply times 25. And the answer would be 56.25 centimeters squared. So that's how you find B. Now let's look at C. If the area of triangle PBA is 100, so PBA is the triangle here, find the area of trapezium. So the trapezium here, QRPA, is the big triangle here minus the triangle here, which is given to you. Again, you need to prove similarity here. Okay, and you prove similarity with these two triangles by first saying that this is common. Angle RPQ equals to angle BPA. Common. That's the first A. Then to prove the next one, you say that this angle, okay, let's just not overlap. So this angle is the same as this angle because they are corresponding angles. So angle RQP equals to angle BAP. corresponding angles because RQ is parallel to BA. So that's the second A. Therefore, triangle RQP and triangle BAP are similar. Once you've proven that they are similar, you can find the area of triangle RQP over the area of triangle PBA will be the scale factor square. So that will be 7.5 over 5 square. So area of triangle RQP is what you want to find. Area of triangle PBA is 100. That's given to you in the question. 7.5 over 5 square. Area of triangle RQP, you just cross multiply. Now some students like to actually simplify this, but I just leave it because that's not the final answer anyway. And I'll press the calculator and let the calculator do the work. So this will give you 225 centimeters squared. So the area of QRBA will be 225 minus 100. That will give you 125 centimeters squared. So that's the answer for C. Now let's look at D. D asks you to find the area of RCB, which is this, to the area of ACQ. Okay, these two white triangles here have no relationship with each other. But what they do have is a relationship with RCQ. So we can use RCQ as an intermediary. So area of triangle RCB over the area of triangle ACQ can be written as area of triangle RCB over the intermediary area of triangle RCQ. And times the area of triangle RCQ as the intermediary, but this time on top, over the area of triangle ACQ. Now, this relationship between these two is one of formula. Okay, so if this formula is half base height over half base height times the relationship of the next fraction or the next set is also one of formula. So again, half base height over half base height. Now immediately you can cancel this half, this half, this height, this height, this half, this half, this height, this height. So the base of RCB, okay, will be the same as the same scale factor. We already know that these two triangles are similar. Okay, I mean this side here corresponds to this side. Okay, the relationship is 5 over 7.5. So I'm just going to put here 5 over 7.5. Then multiply by, now the next one, which is, RCQ over ACQ is also one where the scale factor is 5 over 7.5. Okay, so but this time in the opposite direction. Okay, as you can see, they're exactly the same, just inverse, so therefore it's 1 over 1. So the ratio of the area of triangle RCB to the area of triangle ACQ will be 1:1. Right?